Hey, welcome back everybody. Now the last time we were together, we talked about decks of cards. We basically talked about a deck of cards and a scenario for the entire class period. So let's move on, and for these video sakes, for this video, let's assume this is week 37, Wednesday, Thursday, and we are on the idea of a dependent event given statements. All right? Now, you may have done more and gone into this already on the Monday, Tuesday. You may not even have gotten to the card problems on Monday, Tuesday, depending on the understanding and how good the conversations are in class. All right, so let's get started. A box contains discs, okay, little discs with letters on them shown in the diagram. You randomly remove 4 discs. Ooh, there's a key term. You randomly remove 4 of the discs, one at a time, and set them in a row on the table. What is the probability that the discs you remove will be in order A, B, C, D? Okay, so now draw, yeah, we'll just call them draw. Draw 1, draw 2, draw 3, draw 4. Now, partial credit. There it is. I'm understanding that we're going to draw 4. Okay? So we got a disc, we got a disc, we got a disc, and we got a disc. Now, they want given statements in order. Okay? So, it has to be an A. So again, pause the video. This is how we would like you to study this problem. Okay? Pause the video, and everybody, how many A's are there and how many discs are there? What is the probability that the very first one is going to be an A? Go. All right, welcome back. Hopefully, that was like a 10-minute discussion on working through this whole problem. Okay? Now, I'm going to count my A's, and since I used green, 1, 2, 3, 4, 5, 6. How did you go about counting? Did you go this way, up and down? Why did I start on the back side? I don't know. All right. Now, the very first thing I want to do is I'm going to make a chart here because we're going to need it. To draw an A is 6, 4 times 4, 6 of 16. Okay? Now, hopefully you did that. How many let's change colors. How many B's are there? Because remember, in theory, we got the letter B, the letter D. What? Ugh. The letter C, and the letter D. All right. So now, how many B's are there? B's. 1, 2, 3. 3 of the 16. How many C's are there? 1, 2, 3, 3. 3 of 16. Cool. And the letter D. D. 1, 2, 3, 4. And when you're doing these big, long problems like this, just verify you got it right. 6 plus 3 is 9. 9, 3 and 4 is 7. 9 and 7 is 16. Okay, got it. All right. Now, very first one. What's the probability of getting an A? 6 of the 16. Okay. Now, this represents over here represents independent events. Independent. Okay? On the first pull, probability of an A, probability of a B, probability of a C, probability of a D. There they are. That's the independent. This week, we want to go a step further. Dependent. Now, this is a true statement. True. Okay? Given we drew an A, what's the probability of a B? Okay? So, we got dependent, given. Given an A is gone. B. B was 3 out of 16. We still have 3 of them, but we only have 15 of total. Okay? Given, we got an A and a B, what's the probability of a C? There's 3 C's, but there's only 14 left. Given these 3 events have already happened, 16, 15, 14, there's obviously only going to be 13 discs left. How many of them are the letter D? There's 4. Okay? This represents perfect work. Now the math. What is the probability that the disc you remove will be in order A, B, C, D? Okay, the probability of an A, B, C, D given the order is 6 over 16 times 3 over 15 times 3 over 14 times 4 over 13. Okay, now to speed up the process here, I've already done this calculation, and 6 times 3 times 3 times 4, get 18 times 12. 18 times 12, we get 216 over 16 times 15 times 14 times 13. That's 43,680. Okay, and if we use our calculator to simplify, we'll get down to 9 over 1820. Okay? This answer, 9 times out of 1,800 times will it happen, is not as important as the discussion here. Independent, dependent, with given circumstances, given statements. Given this has happened, what's the probability that that'll happen? All right? You can see we're 8 minutes into the video. I'm going to just do 2 more of these problems. I was hoping the best class discussions would be right here. Okay? I love these types because they're kind of real world. Okay? And we could do this right in the classroom. Okay? How many students were born in this month? How many students were born in this month? What's the probability that one of you listening to this video today has a birthday in the summer? June, July, and August. You could actually do this. All right? So, let's get started. First I'll read it, then I'll ring the bell. The table shows the birth months of students in a class. If 4 students in the class are chosen at random, what is the probability that they will have a birthday in June, July, and August? Okay? Now, if 4 students in the class are chosen at random, what's the probability of June, July, August? So June, July, and August. I'm going to circle that. June, July, August. Those are the ones that we're focusing on. Now, mathematically, we write it like this. The probability of drawing 4 students represented by June, July, and August is equal to, Okay, the table shows the birth month. If 4 students in the class are chosen at random, okay, so just like the deck of cards, okay, what's the probability that the first one is in June, July, and August? What's the probability the second one is June, July, and August? The third one is June, July, and August. The fourth one is June, July, and August. Okay, pause the video, have a discussion. See you in a minute. All right, welcome back. Now, add them up. Got to add them up. We need a total. Okay, so the total students. 2 plus 3 plus 1 plus 3 plus, oh my God, I messed up. Okay, 2 plus 3 is 5, 6, 7, 8, 9, 10, 11, 11 and 6, 17, 18, 19, 20, 21, 26, 28. Did you guys get 28? Do I need to do that again? 7, 10, 17. 17 down here, and 11 there is 28. Okay, I got the same number twice. 28, 28. So we have 28 total students. Okay, next most important number. How many June, July, and August? 2, 3, 6, 9. 9 June, July, August. Okay, I got 9. What did you guys get? That doesn't look like a very good 9, Monty. Okay, all right, so probability. Probability of the first draw, okay, probability of the first draw. Probability on the first draw is going to be 9 of the 228, or 9 of the 28. 9 of 28. Now, the second draw. The probability on the second draw, we already got 1. So now there's only 8 of the possible winners. Only 8 of the students left. And there's only 27 students left. 1 student from June, July, and August has already been chosen. So there's less winners and there's less students. This is like the donut problem. The maple bar is gone. There's less maple bars and there's less donuts. All right. Probability on the third. Probability on the third draw. Third draw. There'd be less winners, less students. And the probability on the fourth draw. Less winners, less students. Okay? And yes, I have that math done. So that'll speed us up here. So we got to multiply all this together. So the probability of drawing 4 students, and they all have birthdays in the summer, is 9 times 8 times 7 times 6 is 3,024. 28 times 27 times 26 times 25 is 491,400. And if we simplify that, we could say it'll happen 2 times out of 325. And that's just using calculator, okay? This is not the key. The key is, did you identify the winners and the totals? The independent event, draw 1, what's the probability? But here's the learning for the week. Given 1 has been chosen, what's the next one? Given 2 were chosen, what's the next one? Given 3 were chosen, what's the next one? All right. Again, we're 14 minutes into class. I'm hoping this discussion went on and on and on. Let's see if we can do one more. Okay. Yeah, this one could take a while. All right. Let's see here. What do we got here? We do the socks problem. All right, everybody. How many people have a sock drawer? How many people have tough time matching all the socks. I got to a point in my life where it's easy to match my socks. I threw them all out. And once a year, I buy a set of socks that all match. I never have to worry about this problem ever again. My granddaughter was over here the other day, and when she packed up and left, she left one sock. She's got a missing one. Okay, enough of that. So, socks. There's a lot going on here. We've got this idea of an addition rule and the probability that one or the other dependent events will occur. We're not going to finish this problem. This is kind of like a challenge problem to you, but we all have a sock drawer. Okay? So what I'd like you to do is read the problem, have a discussion, draw it out, and see how many people have different ways to analyze the sock problem. Okay? Okay, let's read it together. You have 6 blue socks, 8 white socks, 4 green socks, 2 brown socks, and a drawer. Perfect. Get a total. How many total socks are there? That'll be step 1. You randomly choose 2 socks. Close your eyes, pull 2 socks out. What is the probability that the first sock will be a blue or the second sock will be a green? What? This is the first time we had an or statement. This or that. Enjoy the problem. See you in a minute. Okay, welcome back. Now, if you went to the very end of the video 2 weeks ago, the probability of or, okay? So now, the probability of A and the probability of B minus the probability of A and B gives us our answer. What? What is he talking about here? Okay? So, hopefully you guys drew this all out. Okay? How many total socks were there? 6, 8, 4, 2. 6, 8, 4, 2. 14, 18, 20. 20 total socks. Hopefully we agree. 20 total socks? Yep, 20 total socks. Now, we have 6. Let's see. Let's change that. Let's go blue. Remember, partial credit. Blue. 6 of the 20. White. 8 of the 20. Green. 4 of the 20. Brown. 2 of the 20. Okay? This represents the independent. This represents the independent probabilities. Okay? This represents the independent probabilities that any of these things will happen. I pick one out, I get a blue. I pick one out, I get an 8. Okay? So, now, I want to reach in and I want to draw 2 socks. What is the probability of just getting the 2 socks? What's the probability of getting a blue? Okay, now we should all have this. Blue. The probability of getting a blue on the first draw. 6 out of 20. I'm hoping everybody saw that. That's an independent event. Now, let's change colors here. What's the probability of getting a green on the second? And this is where we're going to have the discussion. Okay? Some of you wrote this. Okay? Because one of them is gone. After the first draw, one of them is gone. 4 out of 19. Okay? When we're given an OR statement, it's the probability of the first one, 6 out of 20, okay, which is a blue. And I should have done that. Blue, 6 out of 20. You know what? Let's do that over. Probability of a blue on the first is 6 out of 20. Probability of a green, see how I did that? On the second, many of you wrote 5, green 4. Many of you may have written 4 out of 19. It's not, and I'm going to try to explain it, but we're not going to finish it because we're out of time. It's ready for summer vacation. But this is what we're going to leave you with, is this discussion. Try to make sense of 4 out of 20 plus the probability of a green, 4 out of 20. Okay? The OR statement. The OR statement. Okay? Now, OR statement. Let's go to purple here. Actually, let's go to black. Minus the probability of A and B happening. The probability of A, 6 out of 20, and the probability of green is what you were thinking. There's 4 of the 19. Okay? So this turns out to be 24 over 380. 24 over 380. Okay? So now we combine this. Put these together, and we get 10 out of 20 minus 24 of the 380. And we get our answer, and we'll just use a calculator, and we get 83 over 190. Okay? Now here's the real answer, but here's the confusing piece. What? Where's this come from? Why this? Okay? Why this? Now let's see if I can give you food for thought for the summer. Okay? Now, sock drawer. Okay? Total number of socks. We got some blue ones. We got some green ones. Alright? Now, as we pull them out, we could pull some of these. We could pull some of these. But this 19 right here, okay, on the first pull, we have 20 total. We could pull 6 of these. On the second pull, we have 4 of these. What I need to try to convince you is there could be an overlap here, okay? And when we do this and this, 6 out of 20, 4 out of 20, there's an overlap. We could have the greens and the blues doubled up because of this overlap between the two. So I want you to ponder over the summer. It's not fair to just say half the time. 6, 10, 6 and 10, Why are we not allowing to just think of 10 out of 20? Why, when we Google an or statement, do we have to subtract out this extra piece? Where's this double up coming from that they're talking about? Okay? Now, I know that's not a good way to end it, or is it? The job of a teacher is to challenge you to think about the possibilities. We're going to Mars. First, we went to Mars with a rocket. Then we went to Mars to land on Mars. Then we went to Mars with a remote control device. Then we went to Mars with a remote control device that did things. Now we went to Mars with a remote control device that flies. What's the possibility of the next? Okay? Is there a double up? Is there a reason to subtract this out? Why is it not just 10 out of 20? And they're telling us that we have to remove something. Is there an overlap by analyzing it this way? Have a great summer, everybody. Hopefully you enjoyed it and you can't wait for your next math class. Serious. In fall, I will be back in the building. I hope you all stop by. We can wave, touch elbows, whatever we're allowed to do back then. Wear more masks. I don't know what we're going to be doing. Okay? But I'll be back. See you 1:31. And it was sort of fun to get to know you. You know more about me than I know about you. But I'd like to meet you all next year. Bye-bye, everybody. Have a great summer.